Hey guys, welcome back. So in this video we're going to go over how to write word problems as functions. And the better you are writing word problems or translating these sentences into actual math, the more prepared you're going to be for the harder topics in calculus, which are going to be related rates and optimization. We'll get to those later on in the course, but for now, let's tackle some word problems and see how we can check them out. So let's get started. So every word problem is going to be different. It's not going to be like other topics where they're all going to be very similar. You're going to follow the same steps. But here's the deal. We're going to have many different types of word problems, but we're going to try to tackle them the same way. We're going to follow a recipe in order to be able to figure out the answer with the given information, right? So let's get started. Here we have that we need to identify the blank used in the problem, right? So every problem is going to be about a certain type of topic, right? Certain kind of formula is going to be used. So we need to go ahead and identify that formula or formulas, because once we write the formula, we can see what they want us to do with it, right? And there's no better way of explaining that than by actually doing an example, right? So let's go ahead and read this sentence and then see how we can translate that into math. So here we have a rectangle that has an area of 81 meters squared. Okay, so I have area of 81 meters squared. Cool. So the first thing I do is, one, I write area equals 81 meters squared, and then I also draw a diagram. I'm like, I have a rectangle, so I need to visualize what I'm doing. So I'm actually going to go ahead and draw a rectangle. Well, I had kind of pre-drew that because I suck at drawing. So for you guys, it's going to be much better if I just draw one with the computer. And then we just keep reading the problem and see what they want us to do. So they want to express the perimeter of the rectangle as a function of the length. And we're going to read that one more time to see if it makes any better sense, right? So we need to express, so they're asking us to express something, okay? We need to express the perimeter of the rectangle as a function of the length. So somehow we need to have an equation or a formula for perimeter as a function of the length, right? So this is going to be something that tends to be really confusing, but I want to make sure and clear it up, right? What does it mean when they have as a function of blank, right? As a function of x, as a function of y, as a function of time, in this case, as a function of length, right? What does it mean, or how do I even represent it, right? Well, let's take, for example, f of x, right? Which is one of the most basic examples that we are used to seeing in math, right? And you may not even know what that is now, and it's okay, because professors don't actually explain what f of x is very clearly. And what this means is, right, we have a function f, right? We have a function f as a function of x, right? So right here we have as a function. Let me actually write the whole thing, right? So if I have this is equal to having function f as a function of x, right? So this is something that we already know, right? As a function of x. So whenever they tell us as a function of x, the way we express and the way we represent that is by putting it right here in the parentheses, right? So whatever we're trying to find a function of, in this case is function f, whatever is a function of, we put it in the parentheses, right? So in this case, they're asking us to express the perimeter as a function of the length, right? So what that's going to translate into is that I need to find the perimeter, right? Perimeter, so I put a P for perimeter, as a function of the length. So I'm just going to put as a function of the length. So I put as a function of the length, I put it in the parentheses inside next to the P. I put the L in there, right? So this is my goal. This is what I want to find, and that is the whole reason for my problem, right? Well, here's the deal. We need to identify the formulas used in the problem. So the first thing I'm going to do is I need to find the perimeter as a function of length. Well, what is the perimeter formula? Well, perimeter changes depending on the figure, but in this case we're talking about a rectangle. So how we know perimeter is going to be just normally perimeter is the sum. Perimeter is just a sum of the sides, right? Or some kind of sum of the sides, or you just add up all the sides, however you've been taught perimeter. Or if maybe you've never been taught perimeter, that's still okay. But how are we going to add the sides? Is that we're going to let the longer sides be the length, and the shorter sides be the width, right? So we're going to label the horizontal one the length, and then the vertical one here the width, right? And if the bottom one right here is the length, the one on top is going to be the length as well. And so is going to be the left side. So now you guys see that we have two lengths and we have two widths, right? So if I were to add the whole thing around, if I were to just go around and add this, right, I would get starting here. Let's say I'm starting here. I would get L plus W plus L plus W, right? I'm just adding all the sides because that's the way you've been taught to do that, right? Or for short, we're going to combine the two L's and we're going to combine the two W's, giving us two L's and giving us two W's, right? Okay. So here's the deal. That is a perimeter formula that we have. But what they're asking us to write an equation, right? We need to express the perimeter as a function of just the length. Here, in this part, I'm expressing it as a function of a length and the width, which means, right? Which means that I have the perimeter as a function of two different variables. I want my perimeter just to be a function of one variable, and that one variable is going to be just length. So I need to figure out a way to get rid of this W, right? I need to get rid of that W and somehow turn it into an L, okay? So how am I going to do that? Well, there's a reason why they gave you the first piece of the sentence, right? A rectangle is an area of 81. So we're going to identify the formula that goes with that and see if we can work with that, right? So once we get stuck on our problem, which means we're stuck because we don't have our answer all in terms of length, we need to actually work with it. So we're stuck, we need to get out of that problem. We're going to go run to the other part of the given information, right? So we're going to run over here, which is the area. Okay? So what is the equation for area? Well, you can hear many different types of equations. You can be like it's length times width, it's base times height, it's whatever times I don't know what else. It's just something times something else, right? 2 dimensions. Well, the one that's going to be appropriate for our problem based on how it's labeled, it's going to be where, let's say we say base times height. Well, this is the base and this is the height. Or length times width, this is the length and that is the width. So it's going to be length times width, right? And we know that the length times the width, the area, is equal to 81. So we're going to merge both of these formulas and have 81 equal to LW, L times W, right? So here's the deal. My problem was that I wanted to express my perimeter as just length, right? As a function of just a length. So I needed to get rid of that W. So what I need to do is I'm going to rewrite my W, or I'm going to express my W as a function of L, right? So everything needs to be a function of L, even this W right here, right? So how can I express this W as a function of L, right? Because I want no W's. I want everything in terms of L. Well, I can just go ahead and divide both sides by L. And let's see what I have then. I'm going to have 81 over L is equal to W, right? And I can even change the notation of this W and make it a W in terms of L. Because everything on the other side of the W is whether a constant or an L, right? So that therefore my width is in terms of W. So I'm going to go ahead and replace this W, well, more specifically, this W right here, right, for this W right here. So we're going to change those two W's. And that's getting kind of crowded over there. So we're going to go ahead and solve it over here. Okay? So if I go ahead and do that, I'm going to write P is equal to 2 times L. That's fine because it's in terms of L, in terms of length, plus 2 times the width, right? But I'm going to replace, I'm going to change the yellows. So I'm just going to plug in here, which is the old W. I'm going to plug in 81 over L. Okay? So now, when I do this, I'm just going to have 2L plus, I'm going to multiply 2 times 81. That's going to give me 162 over L. And that is going to be my new expression of my perimeter in terms of W, right? And I can even change this. Well, I'm just going to write another one because I have space. I'm going to make the relation that everything oops, everything that I have to the right of my perimeter equation is an L. It's in terms of length, right? So everything that I have expressed my perimeter as a function of the length, because I've been able to rewrite everything as a constant or as a L, right? So that's kind of how we're going to attack every type of problem. No matter the type of problem that we have, and no matter the word problem that we're going to have, we're going to first start off by reading the problem, go ahead and help ourselves by drawing a diagram or a little picture to see what's going on. And then we're going to ask ourselves, what are we finding, right? In this case, we're finding, so let's go by kind of by steps, right? So we had to make a step one. Step one was read, right? So we make ourselves a little step box. Step problem was just read the problem. Step two was draw. Step three is, what are we looking for, right? So what is the actual question? And then step four is the whole solving part of it, right? So after that, we're going to see what the problem is and how we're going to get rid of it. So we're going to say that the fourth part is just solving it, right? So after we have identified the question, we go through this whole process of solving. But there's a very, very important step here that's going to help us in the solving step, right? And it is, once we identify what we're looking for, right, we write our formula, how we did here, and then we identify the problem, right? Once we identify the problem, so here what we did was that we identified the problem, well, you guys can't see it there, so I'm going to write it here. Identify the problem, and then we go to our given information, right? So the idea is that once we identify the problem, which I'm going to highlight in pink over here, this whole thing in pink, that looks really bloody. Let's try a nicer color, like teal. Right, we identify the problem there in teal, which I'm going to make the relation here that we identify the problem in teal. We need to go to our given information, right? So the given information is in pink, and the given information was this right here. So that's the idea, right? Once we run into the problem of, hey, I want to express my perimeter as a function of length, but I can't, I need to run to my given information, right? So if we run into an issue, we go to the given information. So let's use that method in order to solve the next problem. Here in example 2. Okay. So here in example 2, it's actually going to be a little tougher due to the fact that we're going to have a little more stuff going on, but we already have a nice rhythm of how to solve this problem. So let's start off by reading the problem, right, and then drawing a diagram. So step 1, let's read. An open interval, an open rectangular bin with a volume of 8 meters cubed has a square base. Cool. Express the surface area of the bin as a function of the length of the base. Cool. Let's read that one more time, right? So we have an open rectangular bin. So that means that we're going to have an open rectangular bin. This right here is actually open. I don't know how to make that get to you guys, but that's just open. It's a hole or something. Or it might just be easier to write open. That works a little better. So, and now we're going to say that the volume, it has a volume of 8 meters cubed, right? 8 meters cubed. So we just go ahead and write that down. Then we also have that it has a square base. Well, how am I going to help myself with that, right? So by having a square base, we're going to say that this right here is the base of the rectangular bin. So you have a square base. That means that this length right here is equal to this length right here. So we're going to call both of these lengths just x and x. Right? You guys can call it whatever you guys want. It doesn't matter. Doesn't matter. You guys can call it like length, L. You can call it like width, B, W, or B for base. Whatever you guys want, right? So it even makes more sense to have a B, but I'm going to go with x just because we're used to solving things in x. So express the surface area of the bin as a function of the length, right? So we need to express the surface area. So now we know that since we're expressing surface area, we need to have S or SA. I like SA because that makes more sense to have surface area as a function of the length of the base, right? So we said the length of the base was going to be X, and we can still just go ahead and change it for B, whatever is easier for you, right? So let's go ahead and just leave it as X. So this is what we're looking for, right? So you guys see how the two problems are, they're starting off kind of similar because we're treating them the same way. We're just reading the problem and seeing what we want, right? So let's go ahead and write an equation for surface area, right? Let's go ahead and write an equation for surface area. So what is the surface area, first of all? Because we discussed that the perimeter was just like somewhere on the sides. What is the surface area of a bin or of anything? Well, a surface area can be seen as the sum of the area of all sides, right? So it's going to be the sum of the area of all sides. So I need to add the area of every side. Well, we have an open rectangular bin here. A bin or some kind of box thing usually has 6 sides, right? So that is the first twist about it being an open rectangular bin. It's only going to have 5 sides, or 5 sides that we need to take the area of to find our surface area. So let's start off with an easy side, right? Like the bottom, right? So we're gonna start off with the bottom here. This right here. What would be the area of the bottom? Well, the area is length times width, or 2 dimensions multiplied, and in this case it's a square base. So the area is going to be, we're just going to multiply these two x's. So we're going to say the area is going to be x squared. So when I'm going to write this, I'm going to say that it's x squared. So far, sorry about that. So far we're good because everything is in terms of x. And I'm going to change this whole 5 sides thing and just kind of put it like over here. 5 sides to make ourselves more space. So we have taken care of one of the sides, right, which is going to be the bottom. And then we ask ourselves, usually if we would have a square base, we would also have a square top because that just kind of like goes up, right? So in this case, since we have an open rectangular box, we don't count the other one. We don't count the top. If not, we would just put a nice little 2 in front of the x squared to count the bottom and to count the top. But in this case, we're just going to have an open top, so it's just going to count the bottom. Then we're going to go ahead and talk about the rest of the sides, right? So now that we're done with the bottom, what else can we tackle? Well, what if I just tackle the whole front side? That looks pretty nice to do. Well, the whole front side is going to be the base, which is x, times another dimension, times the height. We're going to say in this case the height is just going to be y. And yes, you can do this with b for x and h for height, and you're still going to get the same problem. You're still going to get the same answer. You guys will see. So if I need to find the area of that front side, the front face, it's going to be x times y. And my question is, how many of these do I have? How many of these do I have? Well, since this is a square base, everyone here, the front side along with the back side, right, are going to be the same. So the front of my square and the back of my square, they're all going to be the same, right? So that's 2 of those that are x, y's, right? But how about these guys? How about the left and the right? Well, those are going to be exactly the same because, for example, I'm going to do it over there like in green. This side, right? This side, which is going to be my right side, it is going to be x times y because it's going to be the base times the height. And the height is going to be the same for the whole bin. So we're going to have a left, and a right. So since we're going to have 2 greens, right? We're going to have one on the right side and one on the left side, and we're going to have 2 yellows. We're going to have a front and a back. Those are all the same because it's x times y. So we're just going to put that we're going to have 4 of those. We're just going to have 4 of those. And then we look at our surface area formula, and there's a problem, right? We have to identify the problem. It is not all in terms of x because I have this y over here. So that's what sucks. So I cannot say that's in terms of x. I am just going to say that I have my surface area equation here, my surface area formula, that I need to fix it, right? So once we have identified the problem, we we go to the given information, which the only given information here that I have, other than being a square base, is that the volume is 8 meters cubed. Cool. So let me go ahead and write that in. I already have that there, right? So let me go ahead and write the equation for the volume. Well, first, let's figure that out. What is the equation for this bin, right? Well, we know that the equation for volume is usually base times width times height, or like length times width times height. Whatever you guys are used to doing is 3 dimensions being multiplied, right? So since we have a square base, that helps things because the base is going to be the length, or the base is going to be x. So is the width. It's also going to be x. And the height is going to be y. So it's going to be x times y, right? So we're going to be multiplying these 3 dimensions all together. X times y. X times y. Or we can also write it as x squared y, right? Since we have the equation now, we can set that equal to the number, which is going to be that x squared y is equal to 8 meters cubed, right? So the idea is that we have to solve for y as a function of x, right? As a function of x, because x is the length of the base. We're saying it's x. So all we need to do is just leave the y by itself. So I'm going to just divide both sides by x squared. So I'm going to have y is equal to 8 over x squared. So once I have that, I'm just going to replace this guy right here for this guy right here. That makes things not too crazy. I'm going to have x squared plus 4x times 8 over x squared. 8 over x squared. And that is going to give me, I'm just going to multiply things out a little bit. I'm going to go ahead and multiply these two numbers out. It's going to give me a 32. And if I cancel this x with this x squared, if I reduce those, I'm going to just be left with 1x on the bottom. Just 1x on the bottom. So I have found my equation for the surface area. There is an alternative way to doing this problem. You can also could have thought of just putting here like length times width times height, and then you could have applied the whole square base, but that just takes longer, right? So if we can find a way to simplify this, we start off by using all our given information, which was that it was a square base, right? So we had to have the x and the x squared for the square base. And if you guys would have done this if you guys would have decided to do this problem on your own and would have used b instead of x, your answer would have been the same thing. It would have just been surface area is equal to b squared plus 32 over b, right? It's the same thing. The only thing that would have changed would have been the x and the b, which doesn't affect your actual answer because we were expressing the surface area as a function of just the length, right? Which means that your surface area in this problem is only being affected by the length of the base. Nothing else can affect it. So that's it for now, and I'll see you guys next time.